think we can kick off. My name is Gabriel Starczewski, and I have the pleasure to lead today's meeting to give you a presentation. So thank you to the committee for inviting me to have this talk. It's good to see you here. So it's nice that you devoted your time to attend this meeting. I'll be talking about performance tests at scale with Azure pipelines, JMeter, and Kubernetes. So something that I had experience with in the past couple of months, and I want to share with you my experiences. So currently I work at a software house called Objectivity in Poland, in Wrocław, and I have a role of a test architect, meaning I mainly deal with designing solution in the test space, a little bit with test ops, because what I'm talking about falls in that dimension, test ops, and that is nothing else as how do we run tests at scale. So test ops deals with solving problems in that space. So running tests at scale, whether these are functional tests or non-functional tests, is all the same. So yeah, let's kick off. All right. The outline for today's talk is the following. So I want to give you a little bit introduction to performance testing in the cloud and mention a few important characteristics that I think are, vital, and one should understand them before we design solutions in that space. Also, then we go and talk a little bit about how to prepare your application for the cloud, and by application I mean JMeter in that particular case, but that can be replaced by any other log generator that you use. So if you prefer Locust or K6 or anything else, you can also kind of use the same pattern that I'm going to present and design your solution with those replaceable elements, I think. However, I did that with JMeter, which is a well-known performance testing tool. I'm mentioning that because what I want to build, or what I want to show you how I build it, is kind of performance cloud. I call it my small blaze meter. Obviously, that's not exactly the same thing, but what I wanted to build in my organization is kind of performance cloud with core elements such as Kubernetes, Azure pipelines, and JMeter. And the question was, how do we do it, right? And I will share with you how I did it, which is one of the possible solutions, but of course not the only one. So when I was tasked with that design of performance cloud, I had to answer a number of questions, and the attempt to answer those questions was something that I called CRUX, which is a small performance framework with all those elements that I mentioned to you that everybody can use because it's available on GitHub. And I will also show you how to use it. If in the future you want to try it out yourselves, then you can just download it and run performance tests at scale with Kubernetes, JMeter, and Azure. So I attempted to answer those questions, and I will show you how. And at the end, because this should not take really more than 20 to 30 minutes, at the end, I think we'll spend most time actually me showing you that, right? So how it operates, because the theory is not really so interesting. I mean, obviously we need to cover it a little bit, but then what's interesting is really how it works, and does it work at all? I mean, is it complex? Is it simple? And you will see yourselves. So performance tests in the cloud. I think that's actually quite a trivial statement, that cloud offers nearly unlimited access to resources for us, for IT people, including storage, compute, memory. And that's great because we can cut slices and pieces from that big cake of the cloud and use it for anything that we want, for running applications, running tests, doing calculations, doing serverless operations, and so on and so forth. And we'll be looking at cloud from the perspective of somebody that needs to run really large tests. However, when we know that cloud offers all these things to us, we still need to remember that cloud has limits and also performance. So Azure, AWS, Google Cloud, they all have limits, and they are usually either subscription related, can be logical or physical. Physical can be, you have a VM and it can only go up to 16 cores and let's say 64 Gs of RAM. Logical can be, you have a VM, but for instance, it's artificially limited to just open 1,000 TCP connections. So it's not a physical limit because any VM should be able to open 32,000 of TCP connections, but on that subscription, it could be limited to 1,000. So if you operate in cloud, then you should also be aware that there are limits to the cloud. So when we use it, and especially when we run tests at scale, then we can hit them. And I did hit them a few times while designing the solution that we're talking about. So the limits are mostly either subscription related or related to cloud performance as such. So a good example of it is how fast your cloud provider can provision a virtual machine. And you are surprised, but sometimes it takes time. From my experience, it can be as long as 10 minutes. So if you plan to automate things, for instance, and you want to dynamically create resources such as VMs, then you should have it in the back of your head that sometimes it can take time because cloud also has limits and performance vary from time to time. So cloud is good, it gives us everything, has some minor drawbacks, but in general, cloud is perfect for tests, any tests, but especially performance tests, because tests are naturally something that is a temporary task. And therefore, infrastructure related to running your tests should exist only during execution of your test suite, for instance. There is no reason why it should exist outside of this process. So when you start testing, you should get resources. And when you end testing, those resources should be gone basically, right? And that's more important in case of performance tests than it is for functional testing, because for performance testing, very often we want to have reserved resources of some sort of some size, and we want to specify this size when we generate load. So if you want to, for instance, run performance tests simulating 10 users, then probably you don't care about resources because any virtual machine can do it. Any build agent can do it, whether it's one core VM or two core VMs. I mean, it's so simple, it's so small that anything will do, even probably an ARM device. But when you think about running tests really at scale, like simulating millions of users probably, then it cannot be any hardware, right? So you want to specify that for this particular test, your demand is for 10 VMs, and when you run a test, it needs to run 10 VMs, and each with 8 cores. So you want kind of specify that at some point, when running performance testing. So it's a little bit side topic, but cloud is perfect for tests because these are usually temporary tasks. What we should store though is data from tests, and data is stored either in form of artifacts. So you can have reports from your test, or it can be stored, it can be sent to something that processes your data in a more advanced way. So for instance, does some kind of anomaly detection, applies business intelligence algorithms and so on. So the recommended way usually would be to send the data, to stream the data to something that can do something more with it, right? So something that is designed to work with data. And Azure, that would be, for instance, log analytics. The last thing I wanted to mention here is that performance tests, from my perspective, are usually more expensive than functional tests for the reason that I mentioned before. So it means that total cost of ownership of running really large tests is higher, and also is one of the reasons why people look at external providers such as JMeter, for instance, and the like, to just migrate their performance testing to to somebody else, right? But why should we be doing that? Maybe we can build it on our own cheaper. And actually, that was something that I had to think about, because I was not allowed to go externally for one particular project that was kind of a trigger for building all these things. So the constraints were, you need to build this in-house, and we need to run really, really large tests, basically without limits, right? So that was kind of a task, and then we had to build, or I had to build that in-house. And when we are designing the solution that should work in-house, it should basically allow us to run any tests when we want. Then the question is, how should we organize ourselves to run around those tests at any scale, any time, for any project? And this is TestOps question for me. So basically, TestOps is a discipline that deals with like enabling really tests at scale, any tests at scale. And it's kind of a mixture of test discipline and DevOps, because you need to apply DevOps principles to enable your tests to run that way, right? So it's kind of a new discipline. Maybe this word shouldn't exist, but for me, it's like combining tests with DevOps. So that's the question. How do we organize ourselves to run performance tests at any scale, anytime, from any project? And you should make basically designing something like that. You should assume that there is no limit, right? So in your organization, you can have dozens of teams that want to run performance testing, each of them in the same time, and then with load that varies from project to project and from run to run. So one run can be something that demands 100 VMs. Another run can be something that demands just one simple VM. But how do we do it so it fills all the use cases? So the natural answer is, okay, we need to make tests cloud ready, right? So we should manage tests and test infrastructure pretty much the same way we do manage applications. So we just need to make our test framework cloud ready. And how do we go about preparing application for the cloud? Obviously, there are many strategies, but one that I think is quite common is that you have your app. And here on this picture, it doesn't matter whether it's JMeter or it's a web application, right? Because it's a pattern. You have your app on your PC, and you want to run it in the cloud so it scales and have all these nice features and uses infrastructure of a cloud provider. So what people generally do is they take their app and they put it inside a Docker container. Why? Because, well, Docker container is immutable. It's like everything inside. So you can ship your system dependencies inside, which is great. It's quite lightweight still. So the first step people do is generally they try to containerize the application. Well, let's say that people usually use Docker for that. So let's put this application inside a container. And then obviously, if you want to scale something, so you want to have multiple instances of our applications, and we want to add some logic to how it scales, scales up, scales down, how it gets created, how it gets destroyed. Then we look at something that can manage multiple containers. So people usually, as a second step, add some kind of container manager for their solution. And that can be Kubernetes or is Kubernetes in my case. Obviously, Kubernetes is much more than just that. But in my case, I'm just using that for managing multiple containers. So people do put applications in the container, then they add some kind of container manager, be it Kubernetes, OpenShift, or anything else. And okay, now we can create multiple instances of our containers and control them. And then you also want to probably your deployment to use resources that are specific to the cloud provider. So if you have 10 instances of your web application, then you'll be also thinking about things how, okay, what about storage? All those nodes should be able to read or write to the common storage. So how do I do it? And then you add to this deployment something that is cloud provider specific. So for instance, storage classes, some kind of monitoring, and cloud providers do have different things for that. For instance, in Azure, you can enable Kubernetes monitoring just with a single click. You can attach their own storage classes, so you can attach storage to running instance of Kubernetes deployment, which is great. So that's how our application progression model evolves. And in terms of tests, when I run tests, this kind of shows what I want to achieve with my infrastructure for my test each time I run those tests. So each time I run my tests, I want that what you can see on the right-hand side of this equation gets created for me for tests. Tests are executed inside that infrastructure. And then when my test is gone, everything gets destroyed and I'm not billed anymore. So I don't pay money for that. All right. So just remember what I told you. I mean, there is no reason for test infrastructure to exist beyond the time span of test execution. I mean, this is like a general statement. So in this particular case, the application will have specific name. So it won't be nameless application. Application is JMeter. So I will use this, or actually I use this approach to put JMeter inside and use JMeter to run those tests in that kind of setup. Now this shows you more like a generic progression from the traditional deployment model to Kubernetes deployment model. That's nicer than my picture. That's why I put it in here. So when you go back maybe to this video in some time from now, then we'll be see, I mean, how people go about, converting their traditional application into something that runs on cloud. And I mean, in the timeline, well, then they usually came from traditional deployment for virtualized deployment, then to containers, and then to Kubernetes. But I think that virtualized deployment can be skipped in many cases. But basically, this shows you how this goes, right? So for any applications, you can go through that path, and then on the left-hand side, you run your application traditionally, and on the right-hand side of this, you run it in the cloud. So it's cloud ready. You made it cloud ready, and this applies the same way for any applications like web app, and also for JMeter. So for testing tools, for instance, because they are also applications. So now let's have a quick look at ingredients that we need for that. So I will just show you how potentially elements that you need to build look like. So I'll show you Docker containers for JMeter, just a quick look, right? Because we don't have time to deep dive into how they are built, but I will show you basically that it's not that difficult to build them. I will also show you what you need to do, or what you should do, in order for your containers to be deployed as Kubernetes, let's say, deployment. And for that, I use Helm charts. So I hope that you'll be able to see or maybe I will do it like this. So just give me a second, because I need to switch now to something else. Okay, now it should be gone, and you should be able to see my entire screen. Okay. And you should be able to see my IntelliJ right now. So if you could just confirm that you can see my IntelliJ, then I'll go ahead and continue. Anybody, please just write on the chat. Yeah, we can see. Okay, I can see. Great. So if you recall this picture where we take like a regular JMeter thing and try to move it to the cloud, and the first step was to put it inside the container. I think most of you should know that JMeter is a Java application, so it's you can download it as a zip file, and inside of the zip file you basically have jar files, multiple jar files. So it's kind of a bundle. That's how you use JMeter. You download the zip file, you expand it. I mean, you unzip it on your disk, and you're ready to go. So the first step would be to prepare a Docker file for JMeter. And the Docker file for JMeter, which I prepared, consists of a number of things, but basically this is all configuration options. So things like you set parameters like in any normal programming language, and you also choose the base which you will use for your container. So I didn't use any really clean and small Docker container here. I used one from Mark Hobson that contained already Chrome and WebDriver, because I wanted also my JMeter to have access to WebDriver sampler and for that to work. But basically, the only things you need to do in order to provide the Docker container for JMeter is obviously to install tools you need in your operating system. So the base of this is actually Ubuntu. That's why I'm saying it's not exactly great, because I should be using something more lightweight, but it serves the purpose of explaining you. So pick the right base, which in this case is something with Chrome. Then you install all the tools you need for preparing Docker container. And then inside the Docker, you'll download JMeter from JMeter homepage, which in this case is tar file. So it's not zip file, but it could be. You unzip it inside the system, and then you do exactly the same thing with any plugin that you want to have inside your Docker container. So you repeat this process like a few times, because in JMeter you can add plugins in a number of ways, but basically one of the simplest is just to put the plugins inside specific directories. In JMeter, there is libx directory. If you put your jar there, then it's kind of installed as a plugin. So, and the plugin you want, you can install this way. So you can actually, like copy paste that from internet. And then you set also some environment variables, like for instance, you add JMeter to the path of your system. So it's available from the command line. And then you set some default JVM arguments. So here I'm setting JVM arguments, and you can override that from outside of the container. So, it's just a couple of lines, so it's not that difficult to build it, and there are many examples of how you do it. The only thing that was important in that particular case is that we didn't just create one container, but we created base container, and then you created a separate one for master, or actually controller nowadays, because master slave is no longer permitted in our world. I hope you know that. And now we should be talking about controller and worker nodes, right? So that's the proper nomenclature. However, you will still find master slave nomenclature in the literature and documentation, because we just got used to it. But I'm mentioning that because when you look at the docs right now, then maybe we are not talking about master slave anymore, but we talk about worker controller. So the first step is to prepare this base image that contains the JMeter and all the plugins inside, and then just build from this base one specific container for the master and one specific container for the slave. And the difference is really very small, because they all contain the same thing. However, in the master, ports exposed are different, and in the slave also exposed ports are different, but it's very much about JMeter architecture, right? So maybe we shouldn't spend a lot of time about it, but I just wanted to give you an example of how a Docker container can look like for JMeter, like distributed mode, and you can go back to GitHub and have a look yourselves. For sure, it can be done better than I did it, but yeah, let's just skip this part. When you have your containers, then the next step was, in my picture, to kind of manage those containers by something that serves the purpose. So basically, that's something that was designed to organize your containers inside cloud environment. That something is Kubernetes, which itself is a program. It's a binary, and it's something that can help you to deploy any kind of workload to the cloud. In the case that we have here, I use Kubernetes to describe the deployment that I want to achieve for my JMeter installation. So let's say I want to run my performance test with 10 slaves, and obviously there also needs to be one master. I want that Kubernetes organizes this for me, and I just tell Kubernetes that I want 10 and it should work, right? So in order to achieve that, what you need to prepare is something that's called the Helm chart, which is not the only way for you to interact with Kubernetes, because there's also cattle commands. However, Helm charts are declarative in nature, which means that you are telling Kubernetes how you want the world to look like. So I want that it all is inside one network, and all those, like JMeter instances, they can connect to each other and they create a distributed JMeter environment. That's what I want, right? And I describe that in the form of a Helm chart, and then Helm creates that for me. So Helm charts is nothing more like a number of, let's say, very difficult to read text files. And I will give you an example of a production kind of Helm chart, because I use it like every day, or almost every day, and how it looks like. I'm saying that obviously before you go to creating Helm chart, you should have some basics of Docker and networking, because kind of it's difficult to create anything in Helm and Kubernetes without doing that. But I assume you kind of have something around those lines, and it's not a problem. Then Helm chart is a number of templates that describe your world, so how it should look like. And Kubernetes alone has concepts of many things that compose a deployment, right? And obviously we cannot cover them here, but what should be creating is basically instances of containers configured in a proper way. And to describe that, what Kubernetes uses are those manifest files. So all those files are called manifest files, and they have YAML format. And you use that language of description to say what should be created for you in the cloud environment. And I'm saying that it's pretty difficult to read, because if I show you like something that's actually real, then it looks like that, right? So if you just swipe through and you look, right, what the hell is that, then yeah, I wouldn't understand it either. So what I want to say to you is that if you go about and want to use Kubernetes in any of your designs, then the only way to learn Kubernetes is by creating a deployment, right? So that's something you completely cannot learn by looking, I think. It's just too complex. It's ugly. I mean, just look at those characters. It's just ugly. It's just difficult to read. And the only way for you to learn is to create one. So for now, what you should understand is that if you want to manage your containers in a proper way, then you should prepare a Helm chart, which is composed of multiple manifest files that you should prepare in YAML format. And those manifest files, they describe all the things, like how many replicas of your containers should be there. So how many JMeters should be there? Should storage be attached there or not? How much perhaps limits should those containers have when running? All those things you can describe in forms of those Helm charts, which is just a number of text files. But as I said, it's difficult to understand them. And I advise that you go and try to create one of your own one time, then it's gonna be easy. But it's the proper way to do it. When I was creating the solution, then I asked my DevOps, well, I want to create this not self-healing, but auto-scaling, meets all demands solution. And I heard that I can use Kubernetes for that. How should I go about deploying that? And they told me, well, multiple ways are there, but if you think about that seriously, you should go and use Helm, because that's the proper way to do it. So yeah, this is more or less how it looks like, and that's not pretty. But if you go and create that, then you are basically ready to deploy your applications to the cloud in a very nice way, because Kubernetes, among other things, give you auto-scalings and similar things. Okay, so it's just a side topic. I just wanted to show you how those components look like if you never solve them, right? So my purpose is not to teach you that because it's impossible and takes really time, right? But let's go back to where we were. So that was a quick look at how those technologies really look like. And from my perspective, I can tell it's not that scary. I think 2 to 3 days and everybody can build Kubernetes handjob. Okay, so in this journey from having an application to something that is ready to be deployed in the cloud, we've already went through creating a container, let's say, and preparing a Helm chart. And that's good, that's the starting point, right? But there are more questions that we need to ask ourselves when we want to build our performance cloud, because up until now, we have something that we can deploy, right? But that's still not enough. Usually what we want to achieve is we want to have a pipeline, and you can see that on this picture because this is direct screenshot from Azure Pipelines, where we test, build, and push our application, for instance, or our container. So we basically incorporate our tests in CI/CD. CI/CD is probably a big word because continuous integration is all about verification, a single change. So you have a change in your code, then you run integrations, verifications, right? And usually people think about it, okay, in my CI, I usually have unit tests and maybe I compile application and build a package. That's natural for languages like Java, which you need to compile. But in general, integration part, so this something that you have in continuous integration, I mean, it can be anything, any kind of verification you just think is okay. I mean, obviously there are good practices, it should be like lightning fast and so on, but in general, it can be anything. It can even be going, to your grandma and asking whether it looks nice, right? It is a verification. It's not particularly suitable for continuous integration, but in general, integration does not only mean, let's say, unit tests and compiling and building package. I mean, you can put anything right there. But in terms of performance testing, I'm not using that statement because there are better ways of incorporating. Well, real performance tests are hard to incorporate like this into CI. Quick performance checks, yes, so there are good tools for that, like K6, Gatling, Locasite, they are probably better for that. But when you build framework like this, which in my case, the biggest use case was to run really massive tests. That's not something you attach to your CI/CD pipeline. That's something you automate, and automation is important. So you should also be able to automate that from the same pipeline where you have implemented your CI/CD processes, but not necessarily I would call it CI. So I'm just to make that clear that when you want to run huge performance tests with 1 million users, then I wouldn't be calling that CI integration, right? But automation for sure. So in theory, you can do it, but the use case that I was focused on was more about automating that for the purpose of running large-scale tests. But obviously, this picture is taken from a real project, and yeah, that's important. So for sure, we need to ask ourselves more questions. For instance, how do we ensure that we have right resources for our test configuration? Because when we have Kubernetes deployment and this Kubernetes thingy can spawn you 10 Docker containers instances. I mean, but it doesn't do it in void. It does create them on the infrastructure that you manage. So how we go about this level down, right? How do we ensure that the right infrastructure exists for the size of our Kubernetes deployment? I can, create hundreds of container instances, but if they run on 2 VMs, then there is virtually no difference whether I have 100 here or 20 or even 10, because they all use the same statically created infrastructure. So how do we go about not only scaling the logical instances, so the container instances, but also the underlying infrastructure? So that's the question to answer. And I will show you 3 strategies to do that I implemented. That's basically the same question. How do we go about integrating tests into a pipeline? And for that, in Azure, you can use something that that is called YAML pipelines. And in my attempt to create that design, I also created starter pipelines for any user. The next question to answer is, okay, we run tests, but we usually also want to visualize them. So we want reports, managers want reports, developers want A/B testing. They want to see whether they are worse or better than previously. Should we go ahead and go to production? So what about our quality case? So what do we do with data, right? And the old approach was we generate some artifacts and then we look at them, right? But it's like old, like nobody does it anymore, or shouldn't do it anymore. What you want to do is you want to stream data into something that can present it, make sense of it, and maybe even do some kind of AI analysis on it. So anomaly detection is a good case. So that's the question to answer. And obviously where to store test artifacts, because you send the data, that's fine, but nothing prevents you also from creating artifacts. So JMeter, for instance, allows you to create an HTML report that people are kind of used to, CSV files, a number of test artifacts. So where do we store it? Because if we run something in the cloud and it's temporary in nature, then of course we can send data to something that is smart, but what about test artifacts? How do we store them? And I will show you how I went about it. And in the attempt to basically create a solution that works, so it's ready for the cloud. And for that, I went through these stages of Dockerization of JMeter and Kubernetization of JMeter. I also tried to answer all these little questions here by preparing something that I called CRUX. I don't know whether you climbed or not, but CRUX is kind of a main difficulty when you climb, and if you solve it, then it's a success. So CRUX means the main difficulty, but basically it's a set of tools that are made to work together based on Kubernetes service from Azure, JMeter, and the pipelines that should make it easy for you to run performance tests at scale while answering all those little questions in here. So I'm going to show you how it works, but the solution is how you can see that on the picture. In this setup, we are executing our tests from Azure DevOps the same way you execute any other tests. So by describing what you want to do in YAML pipeline, basically, because in Azure we use YAML. It's also possible to use classic pipelines when you click things through, but I don't advise you to do it because imagine that in TestOps world, you are given a task to set up 100 new projects in your organization. What would you go and manually click all those things and waste days? No, you would probably do something smarter, which is, for instance, write your pipeline in YAML file and then just upload that pipeline from every project, and you achieve the same thing, but in hours, not in days. So you run tests from Azure DevOps, which is a CI/CD. Well, it's a CI system for Azure. If you don't know Azure, then you can think about Azure DevOps, which we are going to see as Jenkins. Basically, it's like Jenkins for Azure or TeamCity for Azure. If you don't deal with cloud, then that would be the closest explanation of what that is. And then this pipelines tells our Kubernetes cluster, it attaches to our Kubernetes cluster, and it performs Helm deployment. And that's why we needed to create Helm chart. And in this Helm deployment, we create infrastructure that we require for our test to run. So if our test is of type stress test that simulates 1 million users and needs to run on 100 physical VMs, kind of not the right word, on 100 VMs, then this pipeline would tell Azure portal to create that deployment for tests. And that deployment gets created in Azure Portal. So Azure Portal is the place where you create resources that you use in Azure DevOps. This infrastructure is created for you, logical and physical. So logically, you can create 100, let's say, container instances of JMeter. And underneath, for instance, your Kubernetes cluster would scale from 10 VMs to 20 VMs because it would understand that in order to run that load, it needs to scale up the number of VMs that it currently possesses. So basically, that's the flow. Then you run your tests, and this is all automated on that infrastructure. Tests are run, results are sent to Azure Log Analytics for processing. Artifacts are kept and preserved inside your build. And at the end, infrastructure is destroyed. That's simple, right? But in order to do that, we needed to understand that we had to move JMeter from Docker to Helm chart. And then once we had it, it's just a matter of using it the same way we use any other application, really. So besides obviously running workloads on Kubernetes, you can also run tests directly on build agent. So it's without Kubernetes, but that's not fun. That's like running load tests on one VM. It's not fun. It's not test ops, right? Because test ops deals with huge volumes, basically. So CRUX is built on Kubernetes, and it uses Helm chart behind the scenes to create that deployment for you. So that distributed JMeter farm, containers. So this kind of what's inside every JMeter. So for instance, the number of plugins you have inside, what exactly you have inside, they can be swapped by users. So if you want to replace the version of JMeter from 5.4 to 5.2, so downgrade, then you can provide your own Docker container. That's easy to do. But by default, things that you will find there is a number of plugins that people mostly use. You'll also find WebDriver sampler inside with Chrome, because this approach with running JMeter tests on Kubernetes makes it quite easy for you to load test your application with the browsers. So JMeter allows you to write, let's say, code with Selenium. So if you are Selenium testers, then you know, right? You can drive your browser with Selenium. And then why would you be using that approach in JMeter for load testing your application? Well, there is a number of applications that are not really easily testable at the protocol level. And the example that I usually provide is Mendix application. Mendix is a manufacturer of low-code platform that when you look and try to look at the HTTP communication that happens from client to the application, then you will find something that you cannot simply correlate. And I tried a number of times, my colleagues tried, and they found this application, this technology completely, very difficult or impossible to record and replay the way that most performance testers would do it. And therefore, the only approach that was left was to load test this application from browser. And if you have something like that, you can use Docker container to simulate the browser, which JMeter allows you with WebDriver sampler. Then Kubernetes will simply create you 10,000 browsers, and you generate load from those browsers. So that's why WebDriver sampler is inside. It also contains a few nice features like symbol table server, because when you have 20, well, you have a number of JMeter slaves and you want to coordinate test data within them, then you need to use an external component. So symbol table server is included, but you don't have to use it, obviously. Internally, CRUX uses Bash, BATS, which is testing framework for Bash scripts, PowerShell, and Pester. Pester is also a test framework for PowerShell scripts. ARM-TTK or ARM-TTK, which is a test, let's say, harness for Helm charts. So you can run tests against your Helm chart, against good practices, for instance. So in the creation of the CRUX, I use all those technologies, so it's also tested Besides just creating all these elements and automating the approach, it's also properly tested at any level. So you can also test automation, not just code. And before we go to them, I just wanted to tell you about how to manage the resources, because Helm or Kubernetes gives you the opportunity to, scale your deployment logically. So you have 10 VMs, and one test run can instantiate 50 container instances, but they run on these 10 VMs. And then another test run can instantiate 100 VMs, but they still run on these 10 VMs. And sooner or later, irrespective of the number of containers that you want to create, infrastructure size will hit you, will limit you, right? So what are our options to scale infrastructure? The first one is to use a feature in Kubernetes that is called autoscaling. In autoscaling and the mod that is implemented in CRUX, you don't create Kubernetes cluster for each test run, but rather you maintain one all the time. So you create Kubernetes cluster, it lives there, it always exists, but each test run can cause it to autoscale. So if you have multiple tests and you want to run it on your Kubernetes clusters, for instance, in the same time, then Kubernetes can realize that you are trying to run too much workload on it. And it will say, I need to scale up from 20 VMs to 22 VMs, for instance, or from 20 to 30, and I will do it for you automatically. And this is possible. In that case, it's Kubernetes cluster that controls autoscaling, and you as end user, you don't have really direct impact on it. But if you configure your Kubernetes cluster correctly, then it's a good approach. The downside of this approach is you always have Kubernetes cluster. So even if after all the tests are run, you scale it down to one node, then you pay something, right? And it kind of clashes with our approach where we say test infrastructure shouldn't exist beyond the time span of a test execution. But it's doable. It's very often how people do it, because maintaining this almost empty Kubernetes cluster is not that expensive, right? But there are also other options. So that's the base one, and that's the one that people will most likely use. The second one is kind of ideal from cost perspective. So each test case can create infrastructure of its own. And by infrastructure, I don't mean logical deployment inside, like AKS instance that is physically installed on a number of VMs, but I mean, it actually will create a Kubernetes clusters with the desired number of VMs. So each test case can say, for this test run, I want you first to create 3 VMs of that size, with that many cores, with that much RAM. And then on those 3 VMs, please install Kubernetes. So in the next steps, I will organize my logical deployment. So I will deploy there, 10 JMeter container instances or 20, that doesn't matter. But in that case, you also create infrastructure first, then you put your workload on the Kubernetes, and then after the test is run, you destroy it, right? And that's perfect, it sounds perfect. Why people don't do it very often, even in my world? Well, this is related to cloud performance. Creating a VM takes a few minutes very often. Creating a Kubernetes cluster, for instance, 10 VMs can take you 10 minutes, 12 minutes, depends. It takes time. So this approach has certain let's say, weak side of us waiting for the provisioning of infrastructure. This approach is very fast because when you use in the cloud something that exists, scaling it up or extending it is usually faster than creating it from scratch. So creating of a Kubernetes cluster with VM takes time. It's worth doing when your tests are lengthy, when there are really big tests, because we are talking about big tests here. Then 5 or 10 minutes is nothing compared to 6 hours when you want to run really huge load, or 5 minutes is nothing if what you are doing is like simulating the denial of service attack of 10 million users, right? So all those things are acceptable here. And in that case, like, that's fine, right? But if you use often testing and use it often, you run, like 50 performance tests per day, and they are not that big or long, then you would probably be better off with that approach where you maintain a very, very, very thin Kubernetes cluster and only extend it when you run your test. And the third approach would be something that's a mixture of the previous two. And in this approach, test controls the capacity of the cluster, but to certain limit. So test is allowed to create a node pool. Node pool is kind of a like reserved, separate set of VMs inside Kubernetes cluster that is reserved only for that test run. And then after the test is finished, you destroy that pool. What's the difference? The difference is you create something inside existing cluster. So that's nice, but test controls the capacity. That's also nice. So what's the catch? The catch is you cannot create things bigger than what is allowed for you to create inside one node pool. So as I said, cloud also has limits. And for instance, one of the limits can be, I don't recall exactly, but can be in one node pool, you can't have more than 100 nodes, right? So here you would have a problem. Probably you wouldn't have that problem in this approach because here you could create maximum size of Kubernetes cluster. Here you'll be limited by something that exists, and you will also inherit those limitations probably. So the first approach is probably one that's used most in my cases. And now it's time for demo. So I will try to show you all those little things, how they exactly work. Okay, so this guy is talking a lot, and maybe he makes some sense, but can we actually see what he means? Okay, so let's go in here. Well, that we shouldn't see. Okay, so if you want to have a look at basically the solution that's open source, because, well, we decided just to share that with the people because there is nothing really, I would say, that inventive here. It's just a set of automated script. Then you can have a look at the URL that I sent you. This is the main page of CRUX, which basically describes everything that I told you. You can look at what features it has, and also go to installation page. And then installation page, you can figure out how to install it in your project. But before we do it, I just wanted to dwell a little bit for those of you who don't know Azure about the difference between the DevOps and the portal. So what you can see in here is Azure Portal. Azure Portal is the place where you create resources. So if you're a performance tester or architect or anybody that wants to run performance tests and you don't have anything, I mean, you should have money or a subscription, then what you would be doing is, okay, I need access to Azure Portal so I can create resources. That's the place where you create resources in the cloud. The second thing that I need is access to Azure DevOps. Azure DevOps is this equivalent of Jenkins or TeamCity in Azure. So that's the place where you do automation, when you run CI/CD pipelines, and basically where development really happens. This entire SDLC machine happens in here. So that's the place where you use resources, and that's the place where you create resources. So if I'm new to all this and I want to start, then I need those two things in here, and then I'm good to go. So I will go back here and show you what are the installation instructions. So if you want to use my approach, my framework, you would have to download the latest stable version of CRUX, which is basically nothing else as a zip file. This zip file contains all the things that I described to you. So I will unzip it for you. And inside you will find a hidden folder, right? It's not hidden here, a folder called CRUX that contains basically all the automation that you need for performance tests at scale. And it has starter pipeline, starter Azure pipeline. It also has a few JMeter scripts that you can simply use to test your installation. And it has also advanced configuration. So if you are a power user, you want to change things, then you can look in here. But basically, you don't even need to know that to get started. So what you need to do is to copy that folder and then commit it to your repository, which I did for you in here. So usually you will be storing your performance tests in the same place where you store your application code. So inside, there is nothing here, but it could be Python application, .NET application, Java application, Node application, you name it, right? So you store entire CRUX, you just commit it to your repository. Once you committed that, you're ready to go, right? You don't really need to look inside what's here. Just go to your project in your Azure DevOps, and then you'd be creating Azure pipelines. Pipelines is where automation happens. So assuming you committed this, you'd be creating your pipeline. You select the source of your pipeline, which in my case is GitHub, but it could be Azure Repos. It can be anything else really that you can configure, and you choose your application. So what happens when you choose it, you can use an existing Azure pipelines because CRUX provides you with starter pipelines. And then Azure will ask you which one you want. And the one you want is this one. This one is the starter pipeline for CRUX. And now we can save it, which takes probably like a minute. That's what I call cloud performance, right? So performance, cloud has its own performance. Why, for God's sake, it takes so long? I don't know, but there must be a reason for it. So the YAML file is the description of automation that happens when you run tests. Okay, and when it's created, you can run it. And then you get all these options that I described to you during the presentation. So the first one is where you want to execute your tests. And the base option is on build agent, so we're not using Kubernetes. And these are using Kubernetes in one of these three modes that I described to you. So the best way is first to execute that direct on build agent. And when you do it, JMeter is executed using the same Docker containers that we created for Kubernetes, so it stays in family. Then you can configure JMeter arguments, which is JMeter specific, so let's skip that part and just run it, and we leave defaults. So we also specified JMeter scenario file, which is a particular test case that is shipped with CRUX. So basically it's something for you to start, but you'll be writing your own and changing that value to your own test script. And what happens now is the pipeline is executed using the starter pipeline from CRUX. The tests are run inside the container, so container will be downloaded from Docker Hub because those containers, they reside in Docker Hub. And that takes some time. Obviously, you can cache those things, but it takes time. But that's why it's live, right? So I cannot advance the time machine. Just for this case, we just leave it as it is, and for the next two cases, I will advance the time machine because creating a Kubernetes cluster from pipeline will take us 4 minutes, and let's not wait that much time. But just let's wait for that to happen here. Okay, so actually the container has been downloaded. Then our JMeter tests have been run, which you can tell by having 0 errors in here. And then we store and prepare artifacts. We upload things to workbook and archive other artifacts that we need. So let's wait for that to finish. and then I will show you what CRUX gives you. And first of all, it's like verification that your installation is complete, which was pretty simple, right? So when your test is finished, because actual test was run, then your artifacts are published here as build artifacts, and you have here all the traditional artifacts of JMeter, including JMeter report, CSV file, log, and errors, if any. You also have test cases expressed as JUnit tests, which makes it quite easy to evaluate whether a test was pass or a failure. So we can define thresholds based on which the test will be evaluated as a failure. So for instance, you can run a test and it can be successful, so no errors from application, but the response times were unacceptable. So you can define a threshold in CRUX, and then each of these thresholds will be evaluated in form of JUnit test. And here you will be able to see whether those tests actually passed. So it's nice, it features something that we usually want. So additionally, what happened was the data was sent to Azure Workbook. So in Azure, there is Log Analytics Workspace service, which you can use to visualize different data, and CRUX gives you in the default configuration a starter pipeline for a workbook. So workbook is kind of like dashboard in Grafana. So you can install this dashboard. It is stored as JSON file, basically, so pretty much the same way as it's done in Grafana. And you can install it in the Log Analytics Workspace, and it will visualize you all the data from performance testing. And here you can choose the pipeline ID, because we run the pipeline from, we run the test from a particular pipeline, so we can filter by the pipeline ID, by arguments you use, because usually you also want to compare apples to apples and peers to peers, not like apples to bananas and so on. And then you can also do more specific selection, but that gives you all the trending possibilities in here out of the box. It also gives you basic statistics. It gives you anomaly detection as well, because the normal workbook that you use for visualization allows you to have a look at the performance in time. So this is the performance of particular endpoints across the different test runs, and you can make like smart things out of it. But also there is basic anomaly detection provided mechanism with Kusto anomaly detection API, where you can have a look at any of your requests and look for outliers, for instance. So you can use that API to figure out whether there have been any fishy results in here. That won't work because, oh, that works here, okay. Because in order to do anomaly detection, you need to have a specific number of operations, right? So that only works if the sample is big enough. If you have too few observations, then the algorithm cannot, function correctly. That's why it doesn't work for these more stronger filters, but it works here. So basically here we have one anomaly, and the explanation is that's slower than usual. So in CRUX, you have the starter pipeline as well, and all these things happen from here. And as you saw, setup was pretty cool. And you can use just this way instead of Azure Task, because JMeter, there are Azure tasks for JMeter, but you can use it this way without Kubernetes cluster. But what is interesting is how we use it with Kubernetes clusters, because all of these things have not been built for the purpose of automating like small test runs, but for the purpose of automating the big ones. So what I want to do is I want to hit, sorry, that's not this Python. What I want to do is I want to run the test, but I don't want it to be run on build agent. I want to run it on a Kubernetes cluster, and I want to create, let's say, 100 instances of JMeter. Or I will actually create 2 because I'm using free subscription and I wouldn't be able to create. But in normal circumstances, if your subscription is okay, pay as you go, then you can put here 100. So how do we run this on the Kubernetes cluster? And now, first of all, that depends on the mode that we select. So the modes are on existing Kubernetes cluster or on Kubernetes cluster that's created for each test run. So we need to have some way of telling CRUX how to connect our Kubernetes cluster, and we need to create one, because for the first mode, we use existing Kubernetes cluster. So if you are new and you want to progress your tests to Kubernetes, then you would go here, you would create a resource, and you would choose Kubernetes service. You don't really need to know a lot about it. You just select where you want to create it, and then you choose the size. So for instance, you can choose that you want to create 3 nodes and manual scaling, and then you hit create and you get created a Kubernetes cluster. I will actually use Time Machine right now and show you how the Kubernetes cluster created looks like. So Kubernetes is a service, and obviously has a lot of important information for any developer or DevOps, but things that are most important for us is what is physical infrastructure behind it. And you can check it in here in node pools. Our Kubernetes cluster in here has been created on 3 VMs, and each VM is of a certain size. And this size expresses how many cores it has and how many Gs of RAM it has. And in standard DS2v2, I think it has 4 cores. Each VM has 4 cores and 8 Gs of RAM. So in total, we have infrastructure of 12 cores and 24 Gs of RAM to use. Okay, so let's say I want to run my tests this time on this Kubernetes cluster. I need to glue the Kubernetes wish to use from here to the portal. And this glue in DevOps is done by specifying something that is called service connection. So if you go to your projects in DevOps, in project settings, you will have something that is called service connections. And service connections allow you to establish links to resources you want to manage. So if you want to manage a resource from any place on Earth, really, because it doesn't have even to be on Azure, then you create a service connection, and that's the way that CRUX works. So you need to create the service connection of type Kubernetes, and then when it loads, you just provide a name for that Kubernetes service connection, which default for CRUX is K, but you can change it. And then you will select, the instance of Kubernetes cluster. So I need to log in again so that my Kubernetes clusters get displayed. Okay, and then that's the cluster from my portal that I want to use. I just select the name, save, and it's done. It's actually created here, so I won't hit the button. And when you've done that and you go back to your pipeline, that's what K8 connection stands for. So that's basically the glue to Kubernetes cluster. Obviously, you can use also multiple Kubernetes clusters, and the only thing you need to change here when you run tests is the number of Kubernetes cluster. Okay, so now it should work because we choose the mode run on Kubernetes cluster, and we have a working connection to the Kubernetes cluster in Azure portal, and we hit run. And now what will happen, and we specified 2 JMeter slaves. Now we won't run tests from 1 agent, but we will run tests from 2 JMeter slaves, but the entire infrastructure will be deployed via Kubernetes on our infrastructure. So we had 3 VMs, and our 2 JMeter slaves instances will be created on top of that infrastructure. And obviously we can provide different parameters. So we can create 20 JMeter containers on top of 2 or 3 VMs and so on. And here we have endless possibilities of how we manage that. Okay, and it gets created. So I use Time Machine, and one of these runs in here was the one that I'm looking for, where we use the Kubernetes cluster. Okay, and that's the example of how the pipeline looks like. It's a little bit longer, and the reason for that is because we don't just download the container and run tests from the container. We actually make a Helm deployment. So we init the command, which you can see is Helm upgrade, and then what we provide are parameters to our Helm chart, and the name of our Helm chart, the location of those files that I showed you that were included in the Helm templates. So basically, we configure our deployment before it gets deployed. It takes like 2 minutes to get deployed, as you can see, and that's this additional overhead that it's added to this pipeline. And then JMeter tests are run. And in this case, they are run from multiple slaves. So we have one master deployed and we have 2 slaves deployed. So it already runs in distributed mode. And I run it with 2, but I could have run it with dozen or 100, right? That's how it gets. And here we are ready to run really large workloads already. And this is how we do it. What happens inside Kubernetes is a workload is created, and you can see that this workload is created. So inside Kubernetes, and it has a form of specific container instances. We created 2 JMeter slaves. We created 1 master. Each deployment also has its own storage. So the storage is automatically created and attached. And when the test is finished, and it should be finished pretty soon, I think, then all those things would be gone. So the test will actually leave it the same state that the Kubernetes cluster had when test started, right? So basically the end state is the same as start state for the Kubernetes cluster. And it's pretty cool when you run a really large test, but it's not the only. Oh, you see, the test has already been done, and we are deleting the deployment right now. So here in the Kubernetes, you can see that things are being deleted. So storage is being deleted, and the container instances should be killed pretty much soon. Oh, they have been killed already. They are gone. So that's great, right? Because that's how tests should work. Okay, but the last thing I wanted to show you that already gives you lots of possibilities is what happens when you run tests and we use the second mode of operation, which is please create me physical infrastructure for each test run, and on that physical infrastructure install Helm so I can control logical deployment. So in order to do that with CRUX, you just need to change the mode to a case created for each test run. And then you also specify how many instances of containers you want to have. And then instead of Kubernetes connection, you need to specify ARM connection. And there is a difference between the two. So we are creating basically the entire infrastructure from nothing. So we are not using something that's already here, an existing Kubernetes cluster. What we are doing is we are creating it in Azure portal. And for that, you are not using Kubernetes connection. Instead, you are using another type of connection that is called ARM service connection. ARM service connection, which you create pretty much the same way, is a connection that will allow you to create resources in the portal. Obviously, there is security involved in here. So if you allow people, test users to create resources in your subscription, then you run risks, right? But there are ways to mitigate that. So you can just create a service connection that only can do specific things. But it requires maybe a little bit more configuration, not to start with, but to make it right. Then you should probably involve somebody from the DevOps. But if you just want to try it out and your subscription is limited, then you create a regular ARM connection, leave all the defaults, and CRUX requires that it has a name of M. And when you create it, save it, I already did it, so I won't do it again, then you are able to dynamically create resources inside your subscription. So you don't have to have something that already exists. Actually, CRUX will create hit Kubernetes clusters with desired configuration. Okay, so we have this connection. We selected the right mode, and we hit run. And again, this pipeline will take a little bit more time because the Helm deployment took like 2 minutes in that case. So creating the infrastructure will take additional 2 minutes, but all the project managers will be very happy because you are just using the infrastructure you need for the time you need, plus minus 5 minutes for creation and 5 minutes for destruction. But it's great, right? And it's very cost effective. I mean, this approach that I'm showing you here is about 60% cheaper than using external cloud provider for tests such as JMeter and similar. So we did due diligence and it was like, it looks like much cheaper, maybe we do it ourselves. And that was another argument why this thing got created by me. Okay, so what happens in here on top of all rest of the steps, which should give you an overview of what each does, it creates a cluster. And then it has all the same steps that the previous one has. So it just has the creation of the cluster steps and then deletion of the clusters, because we also need to delete the infrastructure. And when you go in here, then you should be able to see that some strange Kubernetes cluster got created here. The name needs to be unique. That's why it's kind of, that's strange. You can control it, obviously, but each test run will create a uniquely named Kubernetes cluster in here. And when it's ready, because as you can see, it's status creating, then the same Helm deployment would happen in here. Same test would be running here. And then everything gets destroyed totally, so nothing left. And that's the perfect solution. However, it takes more time. I will find you an example of this type of successful pipeline. Oh, here it is. You see, create cluster took 4 minutes. So provisioning resources for Kubernetes cluster took 4 minutes. And that's, again, something I called cloud performance. So as you see, cloud is great, but it has its limits, and we had to wait 4 minutes for it to provision us the resources we need. Doesn't matter for really fat testing, but it would matter for quick performance checks, and probably that's not a good approach. But for really big testing, that's acceptable. So this additional 4 minutes comes from creating cluster. Deleting cluster takes 3 seconds, and that's not because it took 3 seconds, but this is asynchronous operation. So you just say, Azure, please destroy it, and you don't need to wait for it to happen. When Azure says, yes, okay, then it guarantees you that it's going to be destroyed. So you don't have to wait for it. But it will also, actually, it will take 4 minutes as well or similar. But the only difference is we don't have to wait for that in the pipeline because it doesn't adapt to any value of what we do. And the same things happen. So we generate test cases, we generate build artifacts, we store them here, we send data to workbooks. And that's just the beginning, because what I need to mention is that obviously this gives you test perspective, but any performance engineer, performance tester knows that in order to know what's the health of your application, you need test perspective, which is data from test. You need telemetry from the application, which is data from what the application saw when it was load tested, and then the infrastructure monitoring. And only if you have these 3 ingredients, then you can say you have good overview of what happened, right? But you need also to have separately the test perspective, because as load testers or performance engineers, we often hit the case where we are testing external sites because somebody contracts us, hey, can you test, I don't know, eBay.com? I mean, I don't have access to eBay infrastructure monitoring. I can provide you with test results, but nothing more. And then you still need it, right? So you need a separate test perspective. That's simple as that. And that's it, really. So if there are any questions, then hit me. I wanted to show you my really adventure of building something that I call my own JMeter or performance cloud that is good for automation and allows me to run any test at scale within a matter of 3 minutes. So some of the things I was looking at when I was designing that was, if I have to go to another project, then I want to spend up to 3 minutes to configure that thing, right? I don't want to go and install things on VMs and then whatever, right? I want just with a snap of the finger, make this project ready for big testing all in-house on Azure, because that's my cloud that I work in, but I wanted that to happen very fast. And with CRUX, I have exactly that. So I just go to project, I install it by committing a folder with a few files that are good starting points, and then I configure service connection, and then I can run it. I can run it with anything that right people will allow me to, because somebody will still tell you, yeah, well, you can run your test, but don't use more than, I don't know, $1,000 per day, right, or something like that. But then it's a different question, because the budget management in Azure is not the scope of this presentation. But technically, you can do whatever you want with that approach, and in a matter of really minutes. And you don't really need to know Docker very much, or Kubernetes. I showed you guys so that you know how it's built. But if you want just to use it, and you can just click it through and it will work, which is another great thing. And no configuration of your own farm involved, and you do everything in-house, and probably certain people can be happy if you do it cheaper than using external services, for instance. And you control all the things, right? So when you create Kubernetes cluster, then one test run can create that Kubernetes cluster in Australia, and another test run can create it in Germany. So you can check different, geographically distributed setups as well. And that's beautiful about cloud. You can create anything you want, just imagine that, and there's automation for it for sure. So that's pretty cool thing, I suppose. All right, so that's it. If you want guys to get in touch with me, and I would like to, because I'm always keen on getting in touch with people that share my interests, even if distantly, but I hope not only, then you can get in touch with me on my LinkedIn profile, which I'm going to send to you, but I'm poor at managing that. Okay, right. So it's on the chat. You can contact with me over LinkedIn. And if you want to try CRUX for yourself, then go ahead, and everything's on the GitHub. Hopefully you'll find a use case. All right, if there's any question, then now is the time.